Hi everyone, and welcome to Breaking It Down with Scott Barber.
Today I want to talk to you about the selfie that took down Twitter. So to really understand what happened, we got to go back to March 2nd and think about what's going on. We've got the Oscars, clearly a big social event. We've got other stuff going on around the world, right? Of course, we've got disruption in Ukraine, creating this background buzz, and all this is kind of fascinating. But to really understand the total impact, let's start by looking at a little bit of a baseline. Let's start with the fact that Twitter, on average, will handle about 6,000 tweets a second. This is huge, but they're used to it. Now, back in just on February 26th, I did some research. I found they hit a peak, a new per second peak of up over 25K. Right? Now that's a huge multiple. No Twitter outage, no downtime, no slowdown. Okay? Now coming into the Oscars, we've got an interesting world situation going on. We've got all kinds of background noise on Twitter related to things going on in the Ukraine and frankly a whole bunch of other things. So we're walking in to the Oscars. Right? If this is the start time in the Oscars, we're walking in floating up near the 20K mark. Twitter's handling things just fine. So now we go in, right? We get a little bit of peak as it comes up. Ellen does her selfie, and we get a peak up into this area. Now it moves pretty fast. That's a pretty high slope, but we're only up into that top range of total tweets. So what exactly was it that took it down? Because we proved just a couple days before that we could handle that total pace of tweets. What the main challenge here is that it wasn't just tweets, it was a picture. And just as a point of reference, a normal tweet accounts for approximately 240 bytes of size. This picture accounted for approximately 33 kilobytes. That's 150 times larger. So over the course of about 40 minutes, there was a million retweets of this, 33K. A million retweets, a 240 bytes. Twitter could have handled just fine. But the relative percentage of pictures during that time frame increased dramatically. Now, under normal circumstances, the way that a distributed architecture would work, like Twitter, right? You've got servers all around the globe, and I'm a lousy artist, but you'll get the picture here that we have multiple servers, multiple locations around the world. Now, if this had been an isolated peak, like the previous record holder for the retweeted picture, which was the 4 more years picture with Obama and his wife, that was very isolated. And so Twitter was able to distribute that load across nearby servers and handle it just fine. In this case, it wasn't just the isolated incident in one area. Over here in other parts of the world, we've got other stuff going on. So we've got all of these servers, all these distributed servers all over the world already operating at high capacity. So the ability to distribute more or less is restricted. So all of these servers over here that could have been used to help use the load were already kind of at capacity. So now we've got all this extra volume coming more or less from a centralized location with fewer systems to handle them. And that fundamentally is what led to the 20-minute Twitter outage. Now what this means is that when we're thinking about developing and designing our load tests, we have to think about more than just how many users are going to be accessing your site. Because user type 1 in Twitter posts a tweet, 240 bytes. User type 2 posts a picture, 33K in this case. Now, under normal circumstances, and I'm sure Twitter has all kinds of data on this, they could tell you exactly what the average percentage of text tweets versus pictures are. And so if you ran a load test and just said, hey, let's go double, then you get this big line and maybe you can handle it. But what you wouldn't get is a change in this distribution. So let's just say, for example, that under normal circumstances, we're talking 1% are pictures. 1 in 100 tweets include pictures. I don't know if that's true or not, but it makes for easy math. Now if I run a second test with the same number of users, and I change that from 1% to 10%, the impact on your servers is going to be huge. In this case, specifically referring to bandwidth. So as you start working on your load testing designs, you've got to think about not just how many users, but you need to think about what they're going to do. You need to think about what are the variables, in this case, file size. In this case, percentage of folks attaching files. And if you don't build in that same kind of variance in your load tests, you can end up with the same problem that Twitter had, where your total number of users is well within your range, but some other aspect, in this case bandwidth, becomes a bottleneck. Thank you.